Hello there. I'm going to be talking about how the cell membrane works. And basically, what it does is keep most things outside of the cell so that it can function properly. And if you're like me and you see a picture like this, you panic. It's like, whoa, 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 whoa. That's way too much information. And this is pretty complicated. So let's break it down a bit. You can basically think of this as a bubble, something that is working as a barrier. And the cell membrane is primarily made of phospholipids. So it is the phospholipid bilayer. Yuck. No one needs a word like that. It is very confusing. So let's break it down because it doesn't have to be this confusing. A phospholipid bilayer is basically two layers of phospholipids, a kind of molecule. And these phospholipids are made up of two components. They're made up of a head and a tail. Now, the head is hydrophilic, which means it loves water, it orients toward water. And the tails are hydrophobic, which means it is water fearing. It will cower behind the heads and avoid water. And the combination of water loving and water fearing is very efficient at keeping things from going across the cell membrane. Outside of the cell, it is mostly water, so the hydrophobic end will prevent that coming through. But of course, you need to let some things into the cell in order for the cell to function properly. So there are various things that are embedded into the phospholipid bilayer or on top of it. But the main way that things get through the cell membrane is through diffusion. Now, this is one way I like to think about it.
It's over, Anakin! I have the high ground! You underestimate my power! It's over, Anakin!
So basically, diffusion is the movement of things from higher energy, from higher concentration to lower concentration. So a place of greater abundance to lower abundance. Now, Obi-Wan has the power. He has the high ground. He has the energy. And he can swamp Anakin, the lower ground, because he has that extra force. And so the force that allows diffusion to occur is the osmotic force. So over time, the natural tendency of things is for molecules to take up as much space as possible. They don't want to be crammed up like this, so they will spread out. And you could see this as the cell membrane, this red line, and this is exactly how things would normally go. But of course, in order to cross the cell membrane, you need to avoid the phospholipid bilayer. And this is where the things that were embedded into the phospholipid come in handy. This is an example of a protein, a channel protein specifically, called aquaporin, that specifically allows water molecules through. So the hydrophobic end prevents most water molecules coming through, but the aquaporin allows water to come through the cell because the cell does need water in order to function. And another example of a protein that can allow molecules through is a carrier protein. It will gobble up molecules from outside of the cell and belch it into the cell. And both of these processes, the protein channel and the carrier protein, require diffusion. So there has to be a greater concentration of the molecules on one side of the cell membrane than the other, so that there's a natural flow from one side to the other. But of course, there are times when this is not the case, where the cell needs more of a molecule, even though it has more of a concentration of that molecule inside of it than in the outside. In this case, it requires energy to pull those molecules through the cell membrane. And energy, and this is referred to as active transport. It also requires a protein, though. I hope that this is helpful, and just as the osmotic force is so important, may the force be with you.